In this problem, we're told a car enters a 300-meter radius horizontal curve on a rainy day when the coefficient of static friction between its tires and the road is 0.6. What is the maximum speed at which the car can travel around this curve without sliding? So what you want to do first is just draw what's going on. So notice what we have is this car, and what you want to imagine is this is the top view, right? And this is just going to be the track. And so we know it's going to be turning around this curve with a radius 300 meters. So we're also told the coefficient of static friction is 0.6, so just keep that in mind. And so what we want to do is just label the forces acting on this. So we know when it's turning, it's going to have a centripetal force going inwards that's pulling it inwards, but it's also going to have the force of friction going outwards. And so the main key about this problem is that you know that these have to be equal in order to prevent it from sliding. Because if one force was greater, it would either slide in or out, right? So because, yeah, if one was greater, it would overcome the other and basically slide. So we need to make sure that these are equal. And since we know the formula for centripetal force, is equal to mv squared over r, we can set that equal to the force of friction, and then we can just go ahead and solve for v, because v is going to be the maximum velocity at which they don't slide. Because when they're equal, right, that's the maximum. So basically, mv squared over r is just going to be equal to the force of friction, and the formula for that is just F sub n times mu sub s, right? Coefficient of static friction. So F sub n in this case is just equal to mg, since that's the only force we have, right, in the y direction. And then times mu sub s. So notice the masses cancel, so we actually don't need the mass to solve this. So you just have v squared times r is equal to g times mu sub s. So you can multiply both sides by r. And then I'm just going to square root both sides, so we only have v. So really the maximum velocity is just going to be g times the coefficient of static friction multiplied by r. So go ahead and solve this. So you're going to do the square root. Keep in mind g is just 9.8. Mu sub s is 0.6. And then r is going to be 300. So yeah, pretty simple problem. Just plug this in now. And when you go ahead and do this, you're going to get it equals 42. So keep in mind this velocity, so 42 meters per second. And if we look here, we can see E, that's going to be your answer, 42, right? So yeah, this is going to be your answer, and hopefully you found this useful.